Hi, Algebra students, and welcome to Lesson 25. We are in the last lesson for Project 5. After you finish this, you can submit the project, and since I've walked through the whole thing, I would expect that you'll do exceptionally well. Because we've had 5 questions in every lesson so far, we're being rewarded with a short set of questions here, only 3. We're still working on systems, but this time instead of working on systems of equations, we're working on systems of inequalities. They're very similar, but they have one big difference, and you'll see as we work through this if you haven't already figured it out in lesson 25. So here's our problem. Trevor is on trial for a shoplifting crime, and he is pleading not guilty. The investigators analyzed some evidence and determined that the criminal's distance from the scene of the crime is represented as a system of inequalities. The first inequality is y is less than or equal to 5x minus 2, and the second inequality is y is greater than x plus 3, where x represents the time in hours that has passed since the incident, and y represents the distance in miles from the scene. As confirmed by a witness, Trevor was seen 7 miles away from the scene of the crime, or from the crime scene, 2 hours after the incident. So 7 miles away, 2 hours after. Use your knowledge of systems of inequalities to determine whether Trevor is innocent or if he could be guilty. Okay, so I'm just going to write these inequalities down so they kind of travel with us down the screen. The first one is y is less than or equal to 5x minus 2. And the second one is y is greater than x plus 3. Okay, those are the two inequalities that make up our system. So the first question is, which answer choice shows the correct graph of the inequality? Well, there's a couple things that we need to be looking for. One, the graph of y is less than or equal to 5x minus 2 needs to have a solid line, okay? And the graph of y is greater than x plus 3 needs to be dashed. The reason is that the greater than symbol means that the points on the line are not included. That would apply to greater than or less than. But the or equal, this little bar underneath, means that the points on the line are included in the possible solution. Okay? So then the next thing we need to look for is that for the y is less than or equal to 5x minus 2, the shading needs to be shaded below the line because we're dealing with less than. And for y is greater than x plus 3, this is going to be shaded above. Okay? Now, the top graph here is going to cross the y-intercept, or our b value is -2, and this one has a b value of +3. All right? This one has a slope of 5, which is very steep, and this one has a slope of 1, which is not that steep. Okay, so we're looking for a dashed, shaded above the line that crosses at +3 and is not very steep. Well, interestingly enough, this first graph seems to fit that bill. It's shaded above here. It crosses at 3. It has a slope of 1. You can see it goes in between, matches the diagonals of each square one at a time. So rise over run is 1 over 1. So that's definitely a slope of 1. This fits the bill for the dashed line. Let's see if it does for the solid line. So if we can calculate our slope here. Let's see if we cross at a specific point, probably here at 8. And if we go up to 13, 1, 2, 3, 4, 5, we go over 1. So that is definitely a slope of 5. It's a solid line. It crosses at -2, and it's shaded below the line. So that shading, what that means is that for this line, y is less than or equal to 5x minus 2, all of this pink area, and including the points on the red line, could be solutions to this inequality. For y is greater than x plus 3, everything that's blue here could be included as a solution to that inequality. So the dashed line then, of course, means that the line itself is not included, so it's just everything above. So the solution set for this system of inequalities is everything that's the overlapped section, okay? As opposed to the system of equations where the only solution would have been right here where the two lines intersect. This solution set is all of this. I went out of bounds a little bit there. This solution set includes everything right in here, okay? So that's the difference between our solution sets for inequalities and for equalities. There's also always going to be more solutions, or usually more. I guess there's a few instances where there are no solutions for systems of inequalities, but there will typically be more solutions for inequalities than for equalities. Okay, so let's erase that and just make sure that this is indeed the graph that makes sense. If we go here, it looks like we have the right lines, but the shading for our blue line is on the wrong side. So the intersection is way down here. This would be y is less than x plus 3, but we want y is greater than x plus 3. So the second graph here won't work. Let's see. This third graph, again, is the right. We've got this dashed and solid in the right place. The slopes are right. But again, the shading is off for both of them this time. This time the y is less than or equal to 5x minus 2 actually is graphed as y is greater than or equal to. The shading is above the line, and vice versa with the blue. Let's see, and the fourth graph, again, everything looks right except the direction of the shading. The blue is correct, but the pink shading is wrong this time. So in all of these graphs, everything is right, but the distinguishing factor is that the only one that has the shading correct is this first graph. Okay, so that took a long time to answer that first question, but there's kind of a lot built into it. Okay, so let's go down to the second question. Since Trevor was 7 miles away 2 hours after the incident, his distance can be represented by the ordered pair 2 and 7. So we want to know, based on the graph of the system, is that in our overlap? So let's go look. Go back to our accurate graph, and we're looking for that point 2 and 7. So we go over to 2 and up to 7, and that is indeed within the overlapped shaded area. So since we know it's in that area, we're going to go down and look at our possible choices here. And it says it lies in the area where the graphs of the two inequalities in the system overlap. It lies in the area that is not shaded by either, and it lies in the area, in the shaded area of one inequality, but not both. So our truth is that it lies in the shaded area of both. Okay, so he was true for both of the inequalities, which means, if we go down to the last question here, explain whether Trevor's location proves that he is definitely innocent. He is not definitely innocent. Because he's in that overlapped area, he could be guilty. So we don't necessarily know whether or not he's guilty. I think we would need a lot more information. Just because someone happens to be within that area, we know there's a lot of points in that area. So what I would say here is this does not, okay, he's in the overlapped area, so this does not prove his innocence, but it also doesn't mean that he is guilty. There are many points in the overlapped area. So they can't exclude him as innocent, but they'll need more info to convict. Okay, thank you very much. That is the end of Project 5. Go ahead and after you finish this one, submit the project, and great job. Take care.